Well, this is the Physics Aviary Photoelectric Effect Lab simulator. And right now, I have 350 nanometer photons impacting on this silver metal plate, and it is not causing the photoelectric effect. These photons do not have enough power to allow the electrons to escape from the silver metal. So what I'm going to do here now is go down and make my wavelength shorter. And sooner or later, oh, there we go. So 210, there's enough. Now these photons have enough energy to cause the electrons to escape. So that's going to be my first data point. So over here on the lab, I have a table here. So I want you to collect 5 different wavelengths that cause the photoelectric effect. And the first one that I got was 210 nanometers. Now when I convert that into meters, it's 2.10 times 10 to the minus 7 meters. You divide it by 10 to the negative 9. I have to convert that lambda into a frequency because that's what we're dealing with is frequency. So you divide the speed of light, 3 exponent 8, by 2.1 exponent minus 7. And that's going to give us the frequency of the photon. And here it's going to be 2.5 exponent 15 hertz. So 2.5 times 10 to the 15 hertz. Now I need to match up, I need to find out what is the stopping voltage for this particular photon, for that wavelength photon. So over here I can increase or decrease my voltage. This is going to push the electrons from the left to the right, and you can see this happening here now. Let's go up to 1.5. That's too much. Let's go down a bit more. So let's try 1.3. What about 1.2? Oh, that's as good as it's going to get. 1.1 is not going to be strong enough. They are going to get absorbed on the other side. So 1.2 volts is our stopping voltage. We'll go back to here. So that's 1.2 volts. And what that's telling us is that the energy given to the electrons by this voltage is equal to the kinetic energy they have when they spring off that silver metal. So this is an indirect way for us to measure the electrons' kinetic energy. We can't measure their speed. It's almost impossible. But we can use a voltage to determine their speed indirectly. So now we're going to get their kinetic energy. And what you do is you multiply the voltage by the charge on an electron. So that's just going to be 1.2 times 1.602 exponent negative 19. And it's 1.9 times 10 to the negative 19. So 1.9 e to the minus 19 joules. So that's how much kinetic energy the electrons have when they absorb one of these 210 nanometer photons. So eventually you're going to graph this over here. The photon frequency will go down on the x-axis, and the stopping voltage is going to go here on the y-axis. And now we just need to get at least four more wavelengths. So I can go up, I can go like down, whatever, just go down by a random amount. And now we have a completely different kinetic energy coming off. So we're going to have to adjust the voltage again. And what you're going to end up with are 5 different combinations of wavelength, frequency, stopping voltage, kinetic energies, and then you'll be able to draw this graph and answer the questions on the lab. And then there's this. You'll have to do this twice. So one will be for one of the alkali metals you're going to choose, and you choose the metal over here. And one of them will be for a transition metal. And that's pretty much it. So, once you've got the graph created, I think it'll be pretty evident how to do the questions after that. But that's your first job, is to gather the data. And, as I said in the lab, I do want like a unique lab for each person and passed it on paper. And so, all of these labs are going to be different.